Welcome to OOTO, the Out of the Office Investigation.
We are so glad you could join us today.
Yeah, we have a really fascinating investigation for you. You know, when you picture the Amazon rainforest, there's this almost overwhelming expectation of boundless fertility.
Oh, absolutely.
You imagine this endless, unstoppable sea of green canopy, thick vines, massive tree trunks. You get the sense that if you were to just casually drop a single seed on the ground, a tree would explode out of the earth overnight.
Right. It creates a brilliant illusion. From the outside, or even if you're just walking through it,
Yeah.
the Amazon looks like the richest, most vibrant terrestrial environment on the planet.
Yeah.
The sheer density of biomass tricks the eye into believing the ground beneath it must be this absolute paradise of nutrients.
But then you actually dig past that thin layer of leaf litter on the forest floor, and that entire illusion shatters instantly.
It really does.
You're not met with rich, dark, crumbling topsoil.
Yeah.
We're looking at an agricultural landscape that is, honestly, an absolute toxic wasteland.
Ex-
The natural soil beneath that lush canopy is a highly weathered, highly acidic red clay. It is almost completely devoid of nutrients.
Because that red clay you mentioned is the definition of an ecological paradox. The heavy tropical rains in the Amazon constantly wash away whatever soluble nutrients might briefly appear. It's this aggressive leaching process.
Yeah, I always like to think of the natural Amazon rainforest as a massive, elaborate trust fund.
I love that analogy.
Right. All the actual wealth, the nutrients, the carbon, the life force, it's entirely locked up in the living assets. It's in the trees, the plants, the monkeys, the insects.
Yes.
It is not sitting in the bank, which would be the soil.
Yeah.
So if a modern farmer comes along and clears those trees to start growing crops, they suddenly realize the bank is completely empty.
And the land goes totally barren after just 2 meager harvests.
Exactly. Which brings us to our investigation today. We are heading deep into the Amazon to uncover the secrets of Terra Preta.
The legendary ancient dark earth.
Yes, and we are looking at how an ancient civilization managed to engineer a super soil that has remained fertile for thousands of years.
And how those ancient lessons might just be the key to our modern agricultural survival. Because it perfectly explains why modern conventional farmers, using slash-and-burn methods, abandon their fields so rapidly.
Right, leaving behind vast tracts of degraded land.
But the historical record provides this incredible, bizarre twist. In 1542, the Spanish explorer Francisco de Orellana navigated the Amazon River.
Wow, 1542.
Yeah, and he returned to Europe reporting that he had seen massive, dense populations. He described sprawling cities, intricate road networks, and huge agricultural fields supporting an estimated 100,000 people living right along the riverbanks.
And for centuries, historians and scientists assumed he was either, wildly exaggerating or hallucinating from jungle fever.
Totally, because the math just didn't work. How could a nutrient-bankrupt, highly leached red clay support a civilization of that size?
It was considered impossible. You're listening to OOTO with research by El Campesino de la Huerta. But fast forward to 1966, and a Dutch soil scientist named Wim Sombroek actually finds the physical proof to vindicate Orellana,
Sombroek discovered these massive patches of coal-black soil.
known locally as Terra Preta.
Exactly, and they were up to 6 feet deep. And this wasn't just a single backyard. It was scattered across an estimated 150,000 square kilometers of the Amazon basin.
Which is roughly the size of the entire state of Georgia. I mean, that is massive.
It is. And the radiocarbon dating of those sites is what truly flipped the scientific community upside down. It proved this dark earth wasn't some natural geological anomaly like a weird volcanic deposit.
Right.
It was intentionally, painstakingly man-made. It was slowly built up by indigenous communities between 7,000 years ago and roughly 500 years before European contact.
That is just mind-blowing.
When you analyze Terra Preta under a microscope and compare it to the surrounding barren red clay, the differences are staggering.
Yeah, the ancient soil contains 3 times more organic matter, 70 times more charcoal, and boasts phosphorus levels up to 20 times higher than the surrounding natural environment.
Which brings us to the ultimate mystery we are investigating today.
Right. How on earth did an ancient civilization, armed with essentially Stone Age technology, manage to create a permanently fertile soil in one of the most hostile agricultural environments on Earth?
They somehow hacked the biology of the jungle.
And it all comes down to a brilliant, perhaps somewhat accidental ancestral recipe?
They avoided the trap of slash and burn. Instead, they utilized a system we now call slash and char.
Slash and char.
Right. They took the resulting charcoal from their smoldering fires and mixed it into massive middens, basically community compost and waste pits.
Okay.
They folded in broken terracotta pottery shards, animal and fish bones to provide a slow-release source of calcium and phosphorus, human waste, and everyday food scraps.
I actually tried to reverse engineer this myself last summer and completely ruined my raised tomato bed.
No.
Yeah, I read about the charcoal, so I just took the leftover raw ash and half-burnt briquettes from my backyard fire pit and dumped them straight into the dirt. I figured, hey, carbon is carbon, right?
Oh, boy.
The plants turned yellow and died within a week.
That is a classic and very common catastrophic mistake. Commercial BBQ briquettes often contain toxic glues, coal dust, and chemical binders that will instantly poison a garden.
Yeah, I learned that the hard way.
And even pure raw wood ash is entirely different from what the Amazonians were creating. Ash is the result of complete combustion, which leaves behind a highly alkaline powder that can drastically alter your soil's pH and burn your plant roots.
So what's the actual secret?
The actual secret ingredient in terra preta is biochar, which is created through a very specific chemical process called pyrolysis.
Pyrolysis.
Yeah.
I spent hours reading the sources on this because it's fascinating. It's essentially baking the organic material instead of burning it. You are heating the wood or plant matter in a low oxygen environment.
Exactly. You're hitting temperatures around 450 to 500 degrees Celsius, but you are intentionally starving the fire of oxygen.
Because the oxygen can't get in to facilitate complete combustion, right?
Right. The material chars rather than turning to ash. This intense, suffocating heat fundamentally alters the cellular structure of the carbon,
Yeah.
leaving behind a skeletal carbon matrix.
You're listening to OOTO with research by El Campesino de la Huerta. And this skeletal matrix is where the microscopic magic actually happens.
It really is.
Because we need to be clear, biochar itself is not a fertilizer. It has zero intrinsic nutrient value.
Zero.
Instead, it acts as a permanent, indestructible sponge. Our sources noted that 1 single gram of this properly made biochar has an internal surface area roughly the size of an entire tennis court.
It's hard to even comprehend that.
Just imagine taking a tennis court and folding it up until it fits on the head of a pin.
That surface area is comprised of thousands of microscopic pores, tubes, and tunnels, the exact remnants of the plant's original vascular system. Furthermore, through the pyrolysis process, biochar acquires a strong negative electrical charge. This is a vital mechanism.
How so?
It acts quite literally like a magnet for positively charged nutrients in the soil cations, like calcium, magnesium, and potassium. The biochar grabs onto these nutrients and locks them into its pores.
Which physically prevents those heavy, relentless tropical rains from washing them away into the river.
Exactly.
It's like they built a fortified underground city for the soil biology. If I were to visualize this for you, the listener, I'd picture a vibrant infographic guide in my mind.
Oh, I like that.
Yeah, and I wouldn't use any stark white backgrounds or text, no white at all. I'd use the deep, dark colors of the jungle. Rich greens, deep ocean, and river blues, dark browns.
Very immersive.
And the text would be light yellow, red, brown, and blue, illustrating the vivid plants, the trees, bright jungle flowers, and rivers filled with bright blue spring water.
That paints a beautiful picture.
And in this vibrant, dark, underground city, the broken terracotta pottery they added acts as the structural condos for the physical soil.
While the biochar's massive network of microscopic pores serves as a micro-hotel for beneficial bacteria and fungi.
But we have to address the exact reason my tomato bed died. Raw biochar is an entirely empty micro-hotel.
Right.
If you put uncharged raw biochar directly into your garden, its magnetic pull is so strong that it will aggressively suck up all the available nitrogen, water, and minerals from the surrounding dirt.
It will instantly outcompete your plant roots and starve them to death. This is known as nitrogen tie-up.
It has to be charged or inoculated first. You have to fill up the micro-hotel with microscopic guests before you bury it in the ground.
Exactly. The ancient Amazonians were basically doing this organically by mixing the char into their waste pits and letting it marinate in nutrient-rich muck for months before it ever saw a plant root.
That makes so much sense.
When you charge it first, this microscopic ecosystem doesn't just hold on to nutrients. It creates a living, constantly expanding biological network.
It fundamentally shifts the capacity of the soil from being an inert medium that just holds roots to functioning as a vital, living, breathing ecosystem in its own right.
Which brings us to the massive wall we are facing today globally.
Yeah, because understanding this ancient microhotel is the key to solving the modern crisis of topsoil degradation. I was looking at the global population projections.
And they are intense.
By the year 2050, we are projected to hit 9.9 billion people on this planet. To feed everyone, agricultural economists estimate we need a 70% increase in food production.
But our current method of intensive conventional farming, which relies on heavy, destructive tillage, chemical synthetic fertilizers, and endless monocropping, has severely degraded our soil ecosystems.
We are essentially doing to the whole world what the slash-and-burn farmers do to the Amazon.
It's terrifying. Studies indicate we've depleted crucial soil minerals by up to 85% in some agricultural areas over the last single century.
We are operating on a severe biological deficit, which is where the concept of regenerative agriculture enters the picture.
It's a fundamental paradigm shift from extracting to restoring. Regenerative soil methods operate on 5 core principles.
Let's hear them.
First, minimize physical soil disturbance, which means adopting no-till practices. Second, keep the soil armored and covered year-round with cover crops. Third, maintain living roots in the ground at all times to feed the microbes. Fourth, radically boost plant biodiversity. And fifth, integrate livestock and animals back into the landscape to naturally cycle nutrients.
And when you look at the raw data, the integration of biochar into those regenerative principles is staggering.
Oh, absolutely.
There was a recent massive meta-analysis of studies coming out of India. It showed that out of all the various regenerative practices tested, applying biochar has the single highest effect size for sequestering soil organic carbon.
Or SOC, as it's known.
Right. It provides a long-term structural stability in the soil that simple compost, which breaks down and oxidizes quickly, just cannot match.
But transitioning a modern chemically dependent farm over to regenerative agriculture isn't just waving a magic wand.
No, it's not.
I want to highlight that fascinating 5-year chronosequence study from the sources. When a conventional farm stops using chemical salts and transitions to regenerative practices, the system actually goes into a state of profound shock.
It's wild. The legacy effects of decades of intensive chemical management mean the natural soil biology is basically extinct.
I think of that like a severe soil detox.
Yeah, the land literally goes through chemical withdrawals before the natural biology can rebuild itself. Initially, crop yields and overall microbial activity can actually plummet.
The farmer looks at their field and thinks they've made a terrible mistake.
But the study showed that if they hold the line, by year 2 of regenerative management, the mesofauna start returning tiny creatures like predatory mites and enchytrade worms.
And by year 5, the entire soil food web shifts completely. It graduates to house complex, larger organisms, crustaceans, millipedes, and larger arthropods.
The biological engine finally turns over and starts running on its own. You're listening to OOTO, with research by El Campesino de la Huerta. And here's where the investigation gets incredibly personal for you, the listener.
Because we aren't just talking about bugs and dirt.
Exactly. The soil's microbiome is, from an evolutionary standpoint, the Earth's digestive system. When we degrade the soil, we are literally degrading ourselves.
There is a direct, undeniable biological link between the living soil you grow your food in and your own physical gut health.
The parallel is impossible to ignore.
There is a direct chronological correlation between the rise of industrial chemical agriculture over the last 70 years and the explosive global rise of ultra-processed foods, or UPFs, and non-communicable diseases like type 2 diabetes, autoimmune disorders, and obesity.
Today, human diets have become dangerously homogenized. Just 9 plant species make up a staggering 66% of all global crop production.
We are eating the same things, grown in the same dead dirt, over and over again.
And here is the mechanism behind why that is so dangerous. Diets that rely heavily on these degraded, uniform, chemically grown crops diminish something called the alpha diversity of the human gut microbiome.
To put it simply, alpha diversity is a measure of how many different types of microbes are living in your gut.
Right. If your gut microbiome is a city, high alpha diversity means you have doctors, sanitation workers, chefs, and engineers all keeping the city thriving.
A low alpha diversity means it's a ghost town with just 1 or 2 rogue gangs running the streets. You are what you eat, eats.
Oh, I like that.
If the plant eats chemical salts from dead dirt, it has no complex nutrients to pass on to your gut microbes.
The downstream effects on human health are profound. Let's look at large-scale health data like the Shanghai Women's Health Study.
What do they find?
Researchers found that higher diet scores, which featured diverse, nutrient-dense, plant-rich foods, are directly associated with vastly increased diversity in fecal microbial gene families.
Conversely, when we look at crops grown in highly diverse, biologically rich, regenerative soils, like a modern terra preta system, those plants are forced to interact with a complex web of microbes and fungi.
And this interaction causes the plant to produce high levels of phytochemicals and antioxidants as a defense and communication mechanism.
And those phytochemicals are exactly what our gut microbes feast on.
Yes. When you eat a carrot grown in terra preta, you are ingesting a complex matrix of phytonutrients that actively restores the alpha diversity of your human gut microbiome.
And since the gut-brain axis relies on those gut microbes to produce neurochemicals like serotonin and dopamine, restoring the soil's microbiome actively restores your own mental health.
Your mood and your overall physical durability. Literally, degraded dirt leads to a depressed human. Living soil builds a resilient human.
Which brings us to the inevitable, glaring economic question.
Hit me.
If biochar can increase crop yields by 16 to 35% globally, if it can capture atmospheric carbon and lock it away for millennia, and if it creates a permanent health-boosting ecosystem, why isn't every single modern commercial farmer utilizing this ancient science?
To understand that, we have to look neutrally at the economics of the modern agri-food system. The global synthetic fertilizer industry is a $27 billion market.
That is a massive industry.
And its entire financial architecture is fundamentally built on a subscription model.
Interesting.
I compare it to a terrible streaming service that you can never cancel.
Right.
Modern farmers are essentially locked into buying NPK, synthetic, nitrogen, phosphorus, and potassium every single year, over and over again.
Because the degraded tilled dirt on a conventional farm is just acting as an inert, leaky sieve that can't hold anything.
Exactly. The farmer applies the expensive chemical fertilizer, the plant takes up a fraction of it, and the rest washes away into the watershed, causing massive algae blooms.
The soil remains dead, so the farmer has to buy the chemicals again the next season just to achieve the exact same yield.
Biochar completely threatens that recurring revenue model because it is largely a one-time application. Once a terra preta system is properly established and inoculated, it acts as a permanent battery. It lasts for centuries.
You cannot patent an open-source, 7,000-year-old indigenous technology.
There is absolutely no recurring revenue stream for massive corporate agribusiness if the soil maintains its own permanent self-sustaining fertility.
But I'd actually push back slightly on the idea of it being a totally permanent, maintenance-free battery. It's vital to understand that living soil is highly dynamic.
Oh, for sure. You're listening to OOTO with research by El Campesino de la Huerta.
I recall a story from the research about an online horticulturist known as David the Good.
Oh, I read about him.
He meticulously built a terra preta trench in his yard. He had an incredible first year, massive yields, perfectly healthy crops. But by year 2, his entire crop failed. Yeah. When he finally dug up the bed to investigate, he found that nearby giant oak trees and a magnolia had actually sensed the dense biological wealth in his trench.
No way.
They invaded the bed and completely choked it out with their feeder roots, stealing all the nutrients for themselves.
That is wild. It proves the soil is almost too rich. The surrounding nature will actively seek out that energy.
It's a brilliant reminder that engaging in regenerative soil methods isn't a factory process where you set it and forget it. You are entering into a dynamic, constant collaboration with a wild ecosystem.
So how do local communities and you, the individual listener, actually ensure local ecosystem success? How do you apply this in your own backyard to improve your longevity, your intelligence, and your mood?
It requires adopting the slow growth mindset of the ancient Amazonians, intentionally avoiding the trap of modern hypergrowth and exploitation.
Let's break down the actual DIY home method, avoiding my catastrophic fire pit ash mistake. How does someone safely do pyrolysis at home?
The safest, most accessible method for a home gardener is called the cone pit technique. You literally dig a cone-shaped hole in the earth.
Okay.
You start a small, hot fire at the very bottom. As it burns down to glowing coals, you continuously layer fresh wood or brush on top of it.
Got it.
This top layer of active fire creates what is called a flame cap. That cap effectively consumes all the available oxygen before it can reach the wood underneath, ensuring the lower layers bake and char, rather than turning to ash.
So you keep layering it until the pit is completely full of glowing black char, but you can't just let it smolder out, right?
Timing is critical. Once the pit is full, You must quench it immediately with a massive volume of water to instantly stop the combustion process.
Because if you don't...
If you let it burn out slowly overnight, you'll just wake up to a pit of useless white ash.
Okay, so you have your wet, raw biochar. The next crucial phase is crush and charge.
Right.
Once it's completely cool, you want to crush that biochar down to about the size of a small pebble or a grain of rice to maximize that microscopic surface area.
And again, do not put this in your garden yet. You have to soak it in a nutrient tea.
How do you make that?
You can make this by mixing kitchen scraps, rich compost, manure, or worm castings into a bucket of water. It might smell terrible, but it is absolute biological gold.
I can imagine.
You let the crushed biochar soak in that tea for anywhere from 2 to 14 days. You're letting that massive microscopic sponge fill up to the brim with beneficial microbes, bacteria, and liquid nutrients.
And finally, you dig and drop. You integrate your newly charged biochar into your garden beds.
The scientific research suggests an ideal ratio of about 1 part biochar to 9 parts topsoil. Or, if you're mixing it heavily into a pure compost blend, you can use a 25% biochar to 75% compost mix.
And to truly mimic the genius of the ancient Amazonian recipe, you should fold in crushed eggshells for calcium, or even small unglazed terracotta shards to provide those structural condos for the microbes.
You are literally reverse engineering an ancient miracle in your backyard.
And by doing this, you're not just growing a better, more nutrient-dense tomato that will heal your gut microbiome. You are actively engaging in a highly localized, powerful form of carbon sequestration.
You are taking organic carbon that would have otherwise rotted on the surface and released greenhouse gases into the atmosphere, and you are permanently locking it into the earth for thousands of years.
It is the ultimate expression of a slow-growth mindset.
The ancient Amazonians didn't just passively survive in a harsh, nutrient-poor environment. They thoughtfully engineered a regenerative solution that solved the exact systemic problems we are facing globally right now.
Carbon sequestration, nutrient collapse, and long-term food security. By painstakingly building the soil biology over generations, they completely bypassed the boom and bust cycle of extraction that characterizes so much of modern industrial agriculture.
And for you listening right now, the takeaway is deeply personal.
Yes, it is.
The quality of the soil you physically come into contact with and the food you manage to grow in it exponentially impacts your own physical durability, your mental outlook, and your longevity.
Building the soil is literally building yourself from the microbes up. We have to fundamentally move past the dangerous illusion that we can continuously extract from the earth without consequence.
Terra Preta proves that human intervention in nature doesn't have to be parasitic or destructive.
It can be profoundly, beautifully regenerative.
Yeah.
We have the capacity to act as a keystone species that actually enriches our environment rather than depleting it.
Which leaves us with a lingering, provocative thought to chew on as we wrap up this investigation.
The indigenous people of the Amazon managed to permanently carbon copy their biological wealth into the earth, leaving behind a living legacy of fertility that has survived and thrived for over 7,000 years.
As we look at our own backyards, our community gardens, and our modern agricultural systems,
What kind of biological legacy are we choosing to leave in the soil for the next 2 millennia?